Okay, so for this question, the first thing that we do is we identify the target and the error. So the x minus 3 tells us that our x target is equal to 3. And remember, we never know what delta is. That's what we're trying to find. So delta is just delta. And then over here with our f of x plus 1 absolute value less than 2, that tells us that our y target is going to be equal to -1. So opposite sign of what is inside that absolute value. And it tells us that our 2, because it's less than 2, that tells us that our error from y target of -1 is going to be plus or minus 2. Okay, so with that set up, let's go ahead and try to find out what our delta value is going to be. So our y target is -1. The error that we identified is that it's plus or minus 2 from that. So we start at -1, we go up 2, so that will end at 1. And then we go down 2, so that will end at -3. Now, by continuing that line, we get our epsilon band. So the epsilon band starts at 1, and it goes to y -3, or vice versa. When it starts at -3, goes to 1. So anytime that I'm within that epsilon band, I will have satisfied that error tolerance that I want for my limit. Now, we're after x. We want to find the error tolerance that is on x. Now, in this case, our target is 3. So what we need to do is we need to figure out where we start and stop in that epsilon band. So the second step here is we are going to say, okay, it intersects, the epsilon band intersects the function here, which corresponds to an x value of 1. And it intersects, the epsilon band intersects the graph here, which corresponds to an x value of 5. Now, what we want is we want an error from the target. So here we are 2 units away from the target on the x-axis, and here we are 2 units away from the target on the x-axis. So we always choose a smaller delta. In this case, we just have one delta to choose, 2 and 2, so we would take delta is equal to 2. So if we take delta is equal to 2, that will ensure that the error for the y-axis for the limit will be equal to plus or minus 2 as well.